The Trustworthy Autonomous Systems node, based at the Bristol Robotics Lab, is a UKRI funded project looking at the design and development of autonomous systems with the ability to adapt and evolve. We study how to design, test and regulate autonomous systems to ensure they're safe, reliable and trustworthy. Working together in a big multidisciplinary team, we've got people from ethics, regulation, sociology, computer science, engineering and robotics. Projects divided into ethics, specification, verification, and regulation across 3 different use cases of soft robots, aerial robots, and swarm robots. This film is to share insights into our work and some of the research outputs we've achieved. The challenge of ethics is to ensure that robotic systems are developed and used responsibly. Soft robotics is a really great area to explore ethics, looking at everything from picking and packing fruit through to medical robotics.
One of the interesting things we found is that people developing technologies will often think in terms of just what's possible, and we've actually been told, I don't think about the ethics. That's for other people to think about. Thinking about a gripper that can pick up delicate food, which could save an awful lot of money for distributors. That's potentially a really positive thing. But if that process becomes automated, lots of people may lose their jobs. That needs to be balanced against potentially cheaper produce. But what we need to think about is how we should develop that technology ethically from the start. It should be an iterative process where we're constantly developing and reflecting. We also perhaps need to have the courage to say, actually, let's stop.
The research outputs of the ethics challenge include a scoping review about the ethics of trust. We've identified the need for guidance for AI use in clinical settings and investigated the ethical views of users and developers. Considering issues like these up front can really prove useful at the specification stage.
Specification is effectively capturing the requirements for the system, what it's supposed to do and what it should not do. That then leads to a formal description of both functional aspects as well as non-functional properties, such as safety and resource consumption.
Swarm robotics looks at how you scale systems to very large numbers of robots. The beauty of swarm engineering is that if you get the right behavior of your robots and those interactions with their local environment, together they can do really complex tasks.
One of the challenges with swarm systems is how to specify them and how to develop safety cases and assurance cases that guarantee their performance as a whole swarm rather than as individual robots.
We've even built in partnership with Toshiba Swarm Arena so that we can trial some of these ideas in an environment that's a little closer to reality.
The Swarm Arena is a fantastic facility because we can operate, control and monitor the swarm in a warehouse setting. It is really important to follow a user-centered design process and investigate how users and operators will interact with the swarm in a reliable manner.
The project is predominantly focused on the trustworthiness of these systems. Specification is important for us to capture what it is we want and we don't want the system to do. So for instance, there is a fire exit and for some reason the robots all congregate in front of the fire exit, the fire alarm goes and they're all sitting there. What do you do about it?
This partnership is really valuable and really exciting to stay at the forefront of the technology and then to commercialize and adapt those technologies into solutions.
In terms of research outputs for the specification challenge, we identified key areas we need to focus on, built frameworks for adaptive systems, and created example cases for these systems. Alongside specification, we also looked at how to verify autonomous systems.
Verification in general is the process used to gain confidence in the correctness of a system with respect to the specification. A system might never do any harm, but unless we are assured of that up front, we might decide not to trust the system. Trustworthiness needs to be demonstrable, and if you've worked with the system for a while and then it surprises you, or it completely fails on you, you lose trust in the system.
The human trials now we're doing with our swarm really are about how do we design these systems so that people who use our swarms feel comfortable using that they understand what the system is doing.
The tangible outcome of this project is our gained understanding of how to design these systems so that they can be verified in the end. Or, alternatively, understanding what cannot be verified. Where are the limits?
The team have made a great start reviewing how to assess trustworthiness. They've come up with a trustworthiness assessment framework and created novel approaches for verifying swarm robotics. To build trust in autonomous systems, verification needs to be considered at every stage of development and is a key part of regulatory requirements. So we rely on regulation to ensure that systems operate in a way that is acceptable.
Regulators, they have to make really complicated decisions about really sophisticated, unpredictable technologies. For example, drones on construction sites that help assist construction workers in their everyday tasks.
In this simulation, we're seeing UAVs flying around, delivering materials to the workers, but at the same time there might be passers-by who are completely unaware of what's happening in the environment, and the UAV needs to react to them differently. Using simulation environments allows us to run thousands or millions of scenarios.
The existing rules, ISO standards and guidelines, they're only useful to an extent.
It's clear that we need to develop new approaches for regulating trustworthy autonomous systems. Our interdisciplinary research has explored the dilemmas in regulating these systems. Our social scientists have explored the largest systematic risks of autonomous technology, and that's provided great evidence for policy development.
I think what is really important is we get ahead of the curve. We don't want to be playing catch-up, which is what we tend to do. Technology develops so fast and regulation develops slowly. What we need to do is this advanced thinking and try to get these processes in place before we actually start introducing the technology.
Our work in the functionality node has shown how multidisciplinary approaches can be used to develop autonomous systems in a responsible manner. We've now got the ability to develop some amazing technologies, and by building on the research in the TAS program, I'm optimistic we can use these in ways that has a real benefit for everyone. Please take a look at our website to learn more about the resources that we've developed.